Good morning, good afternoon, good evening, whatever time of the day it is. Welcome to your lab for today. So for today's lab, we are going to do some experiments on microevolution in a fish pond. Yes, you heard right, in a fish pond. So let me just explain and demonstrate what you're going to do. And if you guys have any questions, you can contact me through Schoology. So, you've got a template again. Make a copy of it and then get to work. Click on this link right here and it'll open for you our virtual lab. Okay? And you can see you're going to read through the background information and answer these questions. I'll let you guys go ahead and do that. It's pretty self-explanatory. Just click on the background information and you read through this stuff and you answer some questions. When you're done, you click on the home button and you go back here and then take a moment and just go through the tutorial, right? It explains everything, right? Take your time, read through it, make sure you understand it all, and then when you're done, go back home. And now we're ready to run our experiments. And so the first thing you're going to do is experiment number 1. You're actually going to do 3. You're going to do this 3 times. The first one we call the control. And you're just going to collect data for 100 generations without changing anything. You're not going to change any of the population demographics. You're not going to change any evolutionary parameters. This is the control. Nothing is changed. This is the one you're going to compare your other experiments to this data, right? This is how science is done. Like when they want to find out, when scientists want to find out if a drug works against a certain disease, what they first do is they give people like a pill with just sugar in it, right? To see what no effect on what effect no drug has on the disease. And then in another group, they will give them the medicine to see what the effect is, and that way they can compare the 2 results to see if the medicine had an effect. So that's called the control of an experiment, and it's usually the one you do first. So we are going to do our first experiment. Now here's a tricky thing. When you click on that, it automatically starts collecting data. See that? It's already collecting data. So you just want to pause that, and then you want to reset that. Okay? And we want to go to the design. So, all right, I'm assuming you already read through the tutorial, so you know what everything means, but I'll explain it as I go through it here. So you've got 2 areas where you can change things. You have the population demographics, right? Those are the size of the population. The carrying capacity is how many fish the pond can support. The ratio of males to females. Mortality has to do with death. So right now 10 die every generation. Brood size has to do with the number of offspring. So every generation 10 new fish are born. And then the initial R allele, that's the proportion of the population that has the dominant allele. Okay? So those are the population demographics. Now here's what we've been talking about with microevolution, right? The evolutionary parameters are migration, right? So you can change the migration rate to make it increase, having migrants coming in. Mutations, right now there's no mutations, but you can change that, right? Later in another experiment. And then here we have fitness, which would be natural selection, right? And then the last one is mating. So right now there is 0 mating selection, right? They just mate with whoever they find. And those are things you can change later. For right now, we're keeping everything the way it is. We're not changing anything, right? And we're going to go to the data, right? And so I'm going to reset this, and then I'm going to hit play and pause right away, right? That's kind of a tricky thing. You got to play and pause because I want to start with my generation 0, and that's what I want to put in to my data table. So at generation 0, right? My population, I'm basically going to just copy down these numbers. My population is 200, starting with a population of 200. And again, if you want to minimize your screen, that way you can see both at the same time. Might be a little bit easier. All right, and I can go like that. All right, and so the dominant allele is, okay, so here what we want to do is we want to convert these into percents, just because it's easier to compare percents than decimals. And it's real easy to do. So if the decimal is 0.46, you're just multiplying these by 100 to turn them into fractions. So you just move the decimal place twice. So 0.46, well, that's just 46%, right? And the recessive allele is 54%. And for the homozygous recessive genotype, that's 22%. And for the heterozygous, it's 55%. And for the homozygous dominant, it's 24%. Okay? So that's at generation 0. And now, what we're going to do is we're going to let this experiment run for 100 generations. So when I'm ready, I push play, right? And it starts going. And you see how slowly it is. And we're going to be here forever if we're going to wait till this gets to 100. So that's why I have this little fast forward button. So just crank it up, and there you see it goes generations. And as you start getting close to 100, you're going to want to slow it down. Otherwise, you're going to go over 100. So this way here, you see the graphs are coming in, right? The data is being recorded. And you see slight fluctuations, but nothing too serious, which makes sense because remember, we're not selecting for anything, right? This is genetic drift. There's no natural selection, there's no mutations, there's no migrations, right? Oh, all right, so here we are, 94, 95. I'm going to slow this down. 96, 97, 98, 99, and 100. Okay, and now I'm going to collect my data for generation 100, population size 204, and 62%, 38%, 16%, 44%, and then it says 0.4, that means 40, right? If there's no number, that means it's a 0. So if you have to move it 2 places, it's still 0.40, which is 40%. Okay. Once you have your data, you're going to go ahead and answer these questions. So which phenotype had the greatest fitness in this experiment? Well, compared to the beginning, what changed, right? We're looking at the phenotypes here. So we've got the white, the mottled, and the red. And so we see that at the end of it, the mottled had a slight, has the highest, right? 44%. So the fitness, again, is the one, fitness means most likely to reproduce. And so if you have most of them, those are ones that are most likely to reproduce. So for my control, the mottled phenotype had the greatest fitness because they had the greatest frequency, right? That's what all these percentages are. They're all frequencies, right? And so what does this experiment prove about microevolution, right? It proves that when there are no changes to the demographics and parameters, the mottled phenotype has the greatest fitness. That's it. That's what this shows, right? So now what you're going to do is you're going to reset the experiment and you'll change one of the population dynamics, right? So we'll go back to the lab, right? And you go back to the design, just click on the button down here, and now you're going to reset it, and you're going to change one of the demographics. Doesn't matter which one it is, right? You can change the initial size, the carrying capacity, the sex ratio, the mortality rate, the brood size, or the initial allele proportion of the dominant allele. Doesn't matter. Just whatever you change it a lot. Change it to its maximum. You want to make mortality rate up, then put it all the way up to 15. Or if you're going to go down, put it all the way down to 5. Make it a drastic change, right? So change one of them, right? And then you're going to run the experiment again. Oh, hold on. Make sure that you, right, you want to get it at generation 0, and then let it go for another 100 generations. And then again, oh, you do have to put a hypothesis this time, what you think is going to happen, right? And then get the data at generation 0, generation 100, and then you're going to compare what you think, from number 7, what you think is going to happen, and you compare it to what actually happened. And then again, which phenotype has the greatest fitness, and what does this experiment prove about microevolution? And then you're going to do it one more time, and this time you're going to change one of the evolutionary parameters. So you'll change migration, mutation rate, with genotype relative fitness that has to do with natural selection, or assortative mating that has to do with sexual selection. Okay? And then you'll run the experiment again, and you'll collect more data. Okay? Just go through the steps again. Again, it's going to ask you what you think is going to happen. That's your hypothesis. Then you collect the data, and then you compare it to your hypothesis. And same thing, which one had the greatest fitness, and what does your experiment prove? And then when you're all done, just go ahead and answer the 3 reflection questions, and then you'll turn it in the same way we turn in Google Docs in Schoology. If you have any questions at all, send me a message through Schoology, and I'll get back to you as quick as I can. All right? Have fun, and I hope you learned some interesting stuff. Bye!